Yesterday we learned that functions relate inputs to outputs. For every input, there can only be one output. To identify a function, you only look at the
input.
The input, the x's. All right. Now I'm going to talk to y'all about function notation. We're not going to really go through this today, but I just want to introduce it to you guys. This is called function notation. Do y'all know how usually our equations say y equals? It's basically, instead of saying y equals, you say f of x equals. It names the function. So this function's name is f. So if I said g of x equals, what's that function's name? G. Why would I do that? Because when I'm comparing a bunch of equations, it gets confusing, so I name them. Like compare f to g. Then you would find the one that says f of x equals and g of x equals, and you would compare them. That's all it is. Got it? So instead of y equals 2x plus 3, it would say f of x equals 2x plus 3. And we would say that's function f. It's just a way to name a function. A function is basically just an equation. Got it? All right. Again, to identify a function, simply check to see that no x repeats itself. Like, this is literally the easiest lesson ever. Y'all are going to love it. All right. Ordered pairs. Write if it's a function or not. Well, again, what do I only look at? So you're going to take your highlighter and highlight the x's. Y'all know that in an ordered pair, the first number is the x, the second number is the y. So I'm only looking at the x. So I have -1, +1, 2, 3, 4. Is that a function? Yes. Why? Because the x doesn't repeat. All right, look at the next one. 2, 3, 4, 5, 6. Is it a function? Yes, it's a function. All right, let's look to the right. I have -1, +1, 2, and -1. Why is this one not a function? The x's repeat, so no, it's not a function. The next one, I have 1, 1, 1, 1, 1. Absolutely not. Everything's repeating on the x's. All right, on a table, exact same thing. You're only going to look at the x's. So I look at the inputs. Is this one a function? -1, 0, +1, 2, 3. Is it a function? Yes. -1 and +1 are two very different numbers. All right, look down here. -2, 0, 2, 4. Yes. Look to the right. 3, 4, 5, 4, 10. Why not? Because the 4s. So no. What about this one? 2, 3, 4, 2. No. The 2s repeated. Go to the back. We learned mapping diagrams yesterday. Remember, mapping diagrams are just a fancy way of making a table. What did I teach y'all yesterday if you don't want to make it a table?
It's the line.
Cover the right side. That's the outputs.
There's a line on every single number.
There can only be one line coming out of every number. So 1, 1, 1, yes. Is this a function? Yes. How about this one? So do y'all see why I said cover up the outputs? Because that's going to confuse you. That it's all going to the 4. We don't care about the outputs. We don't care about them. Does every x have one line coming out?
Yes.
Then it's a function. Okay, go over here. Cover it up.
No.
Why is this one no? The 0 has two outputs. No. How about this one?
No.
What's wrong with it? The -9 has two outputs. That would mean -9 would repeat itself. It would say -9 has this and -9 has this. So no. Now, this is the one I have to really teach y'all because we didn't learn this yesterday. How do you tell on a graph? Well, you could go write down all the coordinates, but that would take a really long time, right? So instead of doing that, you're going to perform a vertical line test. So I'm going to explain. It says, on a graph, if one input leads to two outputs, meaning if an x repeats, you would be able to tell visually because the 2 points would line up vertically. And I will explain, okay? You can do this by performing a vertical line test. So I'm going to take y'all to the one that's not a function so y'all can see why this works. So go to this one. I want you to draw a vertical line. Y'all know what a vertical line is? Straight up and down. Anywhere you want on that picture. I drew it right here. How many times did that vertical line touch the picture? Twice. Right here and right here. If I wrote those as coordinates, look what happens. I am at negative 20, negative 7-ish, and then here I'm at negative 20, negative 12. What do you see about those coordinates? So when they line up vertically, they have the same x. That's why you do a vertical line test. Okay? If they line up horizontally, they don't have the same x. Okay? So this is a no. This is not a function. What about this one? If I draw a vertical line, how many times does it touch? You can draw as many vertical lines as you want, but they can only touch once. If I draw it here, how many times does it touch? So yes, this is a function.
Is that a 4?
What? We don't need the numbers on them. We just need to put a line through it and see if it touches the picture once. If it touches more than once, it's no. So look at this one. There are 2 pieces of this. Does that matter? All that matters is that if I draw a vertical line, it can only touch once. So if I draw one here, how many times did it touch? If I draw one here, how many times did it touch? So is that picture a function? Yes. Remember what I told y'all, functions can look crazy. They can be squiggly lines, they can be curves. They just cannot have 2 x's that repeat. So go to this one. Draw a vertical line. How many times did it touch? Draw another one. How many times did it touch? So am I good? Yes, it's a function. Okay, what about this one? I drew a vertical line. How many times did it touch? How about here? So yes. What about this one? No, you can see it. If I draw a vertical line, it's going to touch twice. That means that x would repeat itself. This is a no. Okay, go to the back page. We're not going to do all these. But I am going to talk to y'all about this one. Can you just have random dots and it be a function? Yeah. What can the dots not do? The x's cannot repeat, so meaning they can't be on top of each other vertically. Look right here. Is that good? But what about right here? How many times did it touch? So no, this is not a function. Do y'all understand why? Tell me no if you don't. You're good? Okay. How about number 4? Is it a function? So if I draw a vertical line, how many dots did that one touch? All right, how about this one? 1, 1, 1, 1. Is this one a function? Yes, because each vertical line I draw can only touch 1 dot, because that's 1 plotted coordinate on that picture. Up here, this vertical line touched 2 plotted coordinates. Got it? All right, go down here. Who can tell me what this means where this dot is filled in and this one's not? Y'all know what that means? Do y'all remember when we learned inequalities the other day? The filled in dot means it's part of the graph. The circle that's open means it's really not part of the graph. Make sense? So this is basically saying this is not a point on the graph, but this is. Does that make sense? All right, if I draw a vertical line, how many times does it touch? Once. Once. So is this a function? Yes. How about that circle? No. Absolutely not, because it would touch twice. It would only touch twice. Okay, look at this one. What do these dots mean? They're not part of the graph because they're open. If I draw a vertical line, how many times did it touch? Once, right here. Once, right here. Once. Is this a function? Yes. Yes. Do y'all have any questions? All right, let me get you your assignment.